Dall-E for image generation, ChatGPT for text generation, and now Sora for video generation. How is OpenAI always building the next killer AI app? And what's even more interesting is that this is OpenAI's competition. The kind of videos they create don't even come close to the quality of Sora's videos. And this narrative plays out for all the previous models as well. You see, OpenAI was never a first mover in the industry. Take GPT for example. The reasons why LLMs have become possible was because of a technique called attention. And this was developed by a Google research team much before ChatGPT, in fact 5 years before. Now similarly, Dall-E was based on a research paper released all the way back in 2015. Yet every time OpenAI has managed to build something that is miles ahead of the competition. So what's the secret sauce that helps them build the best generative AI models? It's actually really simple, and that's GPUs. So before we get any further, let's understand how Sora works. And there are two main techniques being used here: transformer and diffusion. Transformer is the engine behind ChatGPT, and they are made to understand human language. So over here, this is used to rewrite your prompt in a much more visually descriptive way. You'll understand why in a minute. Second is diffusion. This is the technique behind all image and video generation models. Diffusion models are built by teaching the model all the images it has trained on. A good way to visualize is this. If we had to differentiate between a rubber duck and a football, the AI model looks for important factors that can help separate these images on a scale. And the biggest difference here is of course the color. The model starts noticing that the duck is yellow, and if you measure the amount of yellow in the images, that would put the duck at one end and football at another end in this one-dimensional space. Now what if we add a yellow football? Now our color metric just isn't enough. We need a new factor. Let's add another scale for roundness. Now we've got a 2D space with the round footballs at the top and the rubber ducks at the bottom. But what if we want our model to recognize not just ducks and footballs, but everything else that exists? Color and roundness alone cannot be used to differentiate every single object in an image. And this is exactly what diffusion models are built for. To go through all the training data and find variables that help identify objects. They build out a relationship graph over hundreds and thousands of dimensions. This is called latent space. And this is just one step of the learning process. Once you learn image to text, now it's time to reverse the process. The relevant images from your visually descriptive prompt are taken from the latent space and fed into the diffusion model with a lot of noise to make sure we don't create an image that already exists. And the diffusion model is already trained to denoise these images. It combines these images from your prompt in a very small resolution and keeps upscaling it while referencing the real world images to give a completely new and realistic AI generated image. Okay, now if we replace the image latent space with a video latent space, we can start generating videos, right? Well, no. You see, the biggest advantage of diffusion model is it creates a new image every single time. And that is also the biggest problem of creating an AI generated video. You need all the frames of the video to look consistent and not look like they were individually generated. So how did OpenAI manage to use the same diffusion model that wasn't working for anyone else and build Sora? Well, according to them, the major difference is that their model is using something called space-time patches, which means apart from visual factors like colors and shapes, Sora is also learning the space-time factors like movement, fluidity, and whatnot. And here's the fun part: a section in their website shows how Sora works at different levels of compute power. And notice at lower levels, it looks very similar to the other video generators we have. And yes, it's showing basic signs of physics. But even other videos from other AI models show signs of physics. So what's different? It's very clear actually, the GPUs. Now I know what you're thinking. Everybody is training these models on GPUs. So how is OpenAI any different? They're different because they're using more GPUs than any other AI company can even afford. With the help of Microsoft, ChatGPT has trained using more than 4,000 A100 GPUs. While most other software companies are relying on cloud computing solutions, OpenAI specifically partnered with Microsoft, who partnered with Nvidia. So the OpenAI team kind of gets unlimited compute power. But why does having more GPUs means better AI software? Well, to understand that, we need to know what's so different about generative AI models. Both the transformer and diffusion architectures have one thing in common, and that is they are extremely scalable, which means the more data and more compute you feed, the better your model gets at recognizing patterns and variables. Another huge advantage of having your own hardware is that you can choose the exact hardware that can give you a lot more power for a lot less price. For example, this server we built has 2x L40s, which is a recent release in the Nvidia data center GPU lineup. And this has a lot of features that previous GPUs like A100s don't have. Mainly a transformer engine, which is purpose-built hardware in the L40s to boost AI model training and inference times by up to 2 times while costing less. So that was everything you need to know about the new Sora, and in case you're looking for a system to build your own AI model, you can get in touch with our subject matter experts. Feel free to reach us out or email, toll free, WhatsApp, whatever works for you, and we'll be happy to help. Until next time, cheers.